Welcome to your next 5 Caillou challenge entitled Directions Reduction. And for this, you'll notice you're given a string array, and it's going to contain strings as shown in this image here. North, south, you're going to see the 4 main cardinal directions here. North, south, east, and west. They can appear multiple times. And so the idea of the challenge is that you're going to reduce possibly the directions list if they contain redundant pairs that don't really progress anywhere. So for example, consider if you tell someone to go north, let's say each one of these mean 1 mile or 1 block, whatever, however you want to think of it. But if you tell someone to go north 1 block and then south 1 block, they just end up right where they started, right? So hopefully you can see that this pairing is just excess. We don't need it. It makes the directions more complicated than they need to be. And so your task then is to remove these redundant pairings. The catch is that they have to appear consecutively. So if you'll notice in this test 2 example down here, notice when you get the input northwest, southeast, it doesn't reduce at all. You might have thought, hey, the north and the south will cancel out and the west and the east will cancel out. And you'd be right, but per the rules of the challenge that they list here, you can read through this, you're going to find that that should not reduce, and that's why the expected result is the same as the input. Even though I know you just basically, you don't progress anywhere, but that's what they want. It's their challenge, it's their rules. So I think that's all you need to know. Go ahead and read through the whole description if you want. I try not to just read at you. I know you know how to read, but I try to break the challenge down into a simple description to get you off and running. So now would be a good time for you to pause, try the challenge, and come on back when you're ready. I'm going to reformat this because if you're with me still, you know I have OCD by now. Okay, so to get into this, let's solve the problem. My strategy is going to come down to, first things first, I'm going to take this string array and I'm going to convert it into a list, with the idea being that I can remove items from a list and it will kind of shrink in size for me. And so if I have a way of starting with the initial directions list and I sort of go through, say in a while loop, and I keep finding an index that has consecutive values that are opposites, then I'll remove those 2 values and I'll just keep looping and look through the whatever I have left after removing those 2 values, look through it again to see if you find another consecutive pair. If you do, remove it and keep doing that as long as it takes till they're all gone. And then you sort of fall out of the while loop at that point, and you can convert your result from a list back to an array. Note they're looking for an array as the result, and return that. And again, my OCD, they got a capital S here. I don't like that. Lower. I use lower for string mostly. So yeah, that's the plan. How do we go about this? Well, the first part, let's make a list of strings, and I'll call it directions. And I'm going to initialize that to the array. And we know that arrays are enumerable and therefore have this toList method that we've used before. But I will need to bring in length for that. So good, we've just transformed it into a list. Now I can sort of do that manipulation. We know that arrays are a fixed size, right? I can't shrink them and make them longer. I guess we don't do that in this challenge, but we can shrink them. So we've got it in a format that is more convenient to work with. And now what I'm going to do is I'm going to say, I'm going to have this idea of an index. I'm just going to initialize it to some bogus value. And I'm going to make a helper function then that will go through this collection of directions and find me the first index where we have consecutive values that are opposites. So let's use test 1 as an example to visualize. In this case, it would be index 0 my first time through, right? Because I'm choosing to point at the first value, and I'll just say I plus 1 to get the opposite pair. But it's going to return 0 because north and south are opposites, just like east and west are opposites. But I'm starting from the beginning and progressing onward. So what I can do then is, let's make this helper method that can solve that problem for us. So I could call it something like private static int find consecutive opposites. Feel free to spell that out all the way if you prefer. And it will just take a list. And the idea is it just simply returns me that index value, 0 in this case here, but as we remove values, it could be a different index. So for this, I'm going to sort of go over the collection, int I equals 0. I is less than directions. It should be count for a list, if I remember right. It's really unfortunate that some of these collections, they call it length, and others, they call that property count. That's awful, but that's what we have to work with. And so, yeah, I did count -1 because, remember, I'm processing in pairs, right? I'm going to take I and I plus 1. And so I don't ever want to get to this point because there's nothing beyond it, and that would be accessing outside the bounds of the collection. Don't want to do that, bad stuff happens. So that's why I did the -1 there. Strictly less than count -1. Okay, we'll define a scope for this. And so what can I do? Well, you know, sometimes I just write these out in nice ways that are English sounding, you know, and it's like I've described in the other video. You just kind of step down from there, just expose a little bit at a time, you know. And so imagine if I had this method are opposites. I could just take 2 string values and tell me if, you know, it's a north-south pairing or an east-west pairing. Wouldn't that be convenient? Then I could just say directions I and directions I plus 1. I think I'm matched up here. And so if they are, simply return the current I value I'm on, right? And if you get through the whole collection and that never happens, just return -1. Sorry about that. And so of course, you know, we have to implement this function as well, which, as you can imagine, is not difficult to do. So that would be something like private static bool are opposites, and it would take 2 strings, dir2, something like this. And since this is such a simple case, I'll probably just use a simple if statement to do this. You could say if dir1 equals north and dir2 equals south. And you imagine you just have a bunch of pairings of these. So the order could be reversed too, and that's still okay. So I'll say or dir1 equals south, dir2 equals north, right? We don't care about the order, they're still opposites. And then I'll have essentially the same thing for the east-west pairing. So I'm going to do another or and just put this all on a new line. We could go east, west, or west and east. If that's the case, they are opposites, return true. And if you somehow survive that, they'll just say return false. That easy. So yeah, are opposites now. That should be implemented, and this find consecutive opposites then can be expressed very compactly here and in a clear way. If 2 directions, if the current direction and the one in front of it are opposites, return that index, right? Really, I think pretty easy to understand. All right, so now we have this nice helper method. We can do something like this. if index. So what I'm going to do is I'm going to kind of combine updating this index value with the method call. And so we'll pass it directions. And I'm going to enclose this bit so it stays together. And if that's greater than or equal to 0, that means it found a valid index in the directions collection, right? If it returns, we said return -1 if there are no consecutive opposites. So that's why I said in the while loop, if index, which gets assigned this value with the current state of directions, if it's greater than or equal to 0, it means we have a removal to do. Otherwise, we do not. And keep doing it. That's why I used a while loop. We're going to come in here, remove those values, and then directions will be updated, obviously, when we remove those two values. And it'll keep looping until this index finally gets set to -1, and then we break out of the while loop. So you should know list by now, probably. You could go here though, go to your docs. Note I search for C# list. If you go under its methods, you have a remove at, where you provided an index, and it will get rid of that value for you, just like it sounds like. Feel free to read that if you like. So I will say directions, remove at, and it'll be index. And so think about what happens when I do this first one, because what I'm going to do is duplicate it. When I do the first one with whatever index we found, you could think of everything after the index later in the collection is going to shift left. So using our test 1 example here, when I make this first remove at call, it'll be index 0, right? It'll take this north and it will remove it. So then it will be left with this. And you could think of it as shrinking in size and everything I highlighted moving to the left. Or if you want to think of it just like the north is gone, it's the same difference, right? Now south is at index 0, and index 0 is what we want for the second removal then. Hopefully you see why that works. I don't have to say index and index plus 1. Because everything shifts left, we can use the same value twice. And so that will have the effect of removing north-south first, right? And then we go through our while loop again on this collection. Our find consecutive opposites will start at 0. It'll look at south and east. For its first pair, it'll say, nope, those aren't opposites. Then it'll go to index 1, I equals 1. It'll go east-west. It will find those. We'll get remove at index 1. It'll remove east. Everything from west on will shift to the left, so to speak. And then it will pull west out of directions at index 1. And this process continues until there is nothing left. And let's see, did I do anything? We're using lists, so I should bring in using system collections generic. Let's give this a whirl. And I'll code paths return a value starting at line 7. Oh sure, I never even returned the result, did I? So we have to return directions, but remember directions is currently a list, so I'll say to array. Let's see where that gets us. Good, green, and we'll make sure we have it for the larger test suite, and we nailed it. So couple things, again, if you're ever getting stuck on these things, use console log and write out your variable values so you can see how this thing is progressing. That's very helpful when it's not, or it doesn't seem to be behaving like you expect it to. The other notable point, again, I try to stress, break things out in separate methods. You know, you've got these nice helpers here, and it made life up here super easy, right? We're doing exactly what the instructions told us in clear English. I mean, I think someone who doesn't even code can understand this, or at least what it's doing. Maybe they don't understand how the computer works, but they can understand what's going on here. And so, yeah, keep finding consecutive opposites. They had to be consecutive per the rules. That's why we did it this way. and then index keeps getting updated until there are no more pairs to remove. Index becomes -1 at that point. That is not greater than or equal to 0, and you break out and finally return your collection in the array form that's part of the contract. For the helper methods, they're private. They have nothing to do with outside users of this class. That's why I made them private. It's just completely unnecessary for me to make them public. People who are consuming my class don't even need to know about this. I like to think of this as my scratch pad, you know what I mean? It's like my workspace behind the scenes. It's like in the kitchen of a restaurant, right? You don't see back there. You could if you really wanted to, and people can come in the class and look at that, but if you're a busy waiter, you just want to say, hey, give me a cheeseburger order or whatever. You don't want all this other stuff getting in your way and slowing you down. It's the same here. Put your public stuff right at the top, make it readily viewable so people don't have to scroll through in a mix of private and public stuff. In this case, it's super easy, right? There's only one public method. There's only one thing you can do with this class. Isn't that nice? If you had to work with somebody else's code, you know what your limitations are, what exactly you're supposed to do. So that's sort of the concept here. And then, yeah, slowly stepping down. Could I have put the R opposites implementation all in this method? Sure, and it's small enough where it wouldn't be terrible, but this kind of approach will be your friend even when you get into larger scale projects. So yeah, you just expose a little bit at a time. Keep sort of delegating the work downwards, I like to think of it as. So reads really nice, it's clear. If you look at any one method, they're incredibly simple and anyone can understand it immediately. So that's probably all I have to say about that. I'll go ahead and fire mine off. I didn't have any comments in here to remove. So yeah, see what you can learn from others. Hit me up in those comments if you took a different approach to this. Otherwise, yeah, I'll do what you do and just check through some of these solutions, see what we can find. I like to vote and give people credit too when they do good answers, so I'll give them a best practice or a clever upvote when I see that stuff. So that's kind of a nice thing to do for people. Otherwise, hit me up with your questions and comments, or we will keep rolling. See you later.